Welcome back. We're still continuing our discussion on intermolecular forces, but we're going to take a sidetrack and go to discuss phase change because you have to understand what is happening between the three phases of water before you can answer some of the conceptual questions I posted. And we will tie all this back to what we learned with vapor pressure and boiling point and stuff like that, right? All right, without further ado, let's get started. Now this right here, what you see in front of you, this little graph is called a phase diagram. Okay. This phase diagram is a two-dimensional view of what happens to water when you can actually plot this as a function of pressure versus temperature. Now we would again come back and tie and learn the concept of pressure and temperature and volume when we learn kinetic theory of gases and gas laws. But this is all the foundational where things start, right? So here we have our y-axis, which is pressure, and our x-axis is temperature. And the substance we're going to deal with is water. This is a classic phase diagram of water. Not just any substance. Each substance would have its own phase diagram, but this is water because water is a substance. It's easy to work with, right? Now I'm going to label some numbers here. So I'm going to call it 2, right in the middle as 1, and this is 0. Now before we get going on explaining this, I want you to bring to your attention two terms. One of them is STP. What does STP stands for? It's called standard temperature and pressure. Okay. When you refer to the words STP, which again you will see in gas laws, is these conditions are constant. And what is the standard temperature and pressure? It's 0 degrees Celsius or 273 Kelvin, and pressure is 1 atm or atmospheric pressure, right? Now, whether a liquid boils, freezes, or any of the other processes that can happen to water has to happen under these conditions, which is 0 degrees or 273 Kelvin and 1 atmospheric pressure, right? So this is solid, this is liquid, and this is gas. So this is just liquid water, which is liquid. This is water in its steam or gaseous form. And this is water as ice, which is solid, right? So to go from solid to liquid, the temperature, the pressure must be 1 atm. Okay, I'm going to draw a line. And if you start putting temperature values here, you would see that solid to liquid, solid goes to liquid at 0 degrees. Okay, now water is a classic substance, which is why I chose to discuss the phase diagram of water. At 0 degrees Celsius, water exists in both solid and liquid form, and then when you get slightly past 0 degrees, then you end up purely in the liquid. You see right at this form, you have a slurry of solid and liquid, right? And this is called the freezing temperature, right? Now let's say if we go a little bit further into this zone right here, then we have pure liquid, right? And then let's say we're heating up a liquid, right? So let's draw this line further up. Let's extend this line up. Okay, now let's say our water is in the liquid phase, right? And then we draw the line all the way till it touches the curve and then drag it down. Okay, this would be 100 degrees Celsius. right? Now, when I explain the heating curve, all this would again make more sense. Just different way of looking at it, right? So at 0 degrees Celsius, solid and liquid are in combination. When you go slightly below 0, then you're purely in the solid state. When you go slightly above 0, you're purely in the liquid state. And at this point, you have both liquid and gas in constant equilibrium, like liquid becoming gas, gas becoming liquid. But when you go slightly to the left, you're in the liquid. When you go slightly to the right, you're in the gas form, right? Now, all this can be explained by certain common terms. When solid goes to liquid, it's called melting. That is, when you go this way, right? I'm going to switch colors here. When you go from liquid to solid, which is this, it's called freezing. And let's get another color. Say liquid to gas, which is going from here to here, it's evaporation. And when you go from gas to liquid, that's called condensation, which is this. Solid to gas, which is this right here. I'm gonna have to switch colors here. Okay. Let me get, actually that color might just work. Let me get a different color, slightly different shade of a red. So this is solid to gas, which is called sublimation, and gas to solid, which is, I'm gonna have to pick another color, which is this, is deposition, right? So these are the 6 major phase changes that can happen with water. Water is such a unique substance that it can do all of the 6 things, all right? This is the most you can have, right? Other substances, not so much. They can't do everything, right? They can't go from solid to liquid all the time or liquid to gas. Water is such a unique substance that we can do all this, right? So the take-home message from this is, I want you to remember this, STP, which is standard temperature and pressure, which is 0 degrees or 273 Kelvin. You should always use Kelvin in mathematical problems. You don't want to use 0 degrees because that will give a slightly different answer. And you also want to remember it's 1 atmospheric pressure. Now, another term that I want you to get used to it is enthalpy, which is indicated by a delta and the uppercase letter H. What is this enthalpy? It's nothing but heat change. Okay? So when you go from, in the next video, we're going to try to do a problem that would make a little bit more sense in the context of a heating curve. Let's say you are at a liquid, you have water and you're boiling, right? You're putting in heat to convert a liquid into its gaseous form, right? How much heat is absorbed by the water is this enthalpy, right? Which is the heat change. That is, when water is not boiled and when water is boiling, how much heat has been absorbed by 1 mole of water to go from a liquid to a gas phase. It's basically a difference from what is before and what is after. Delta in chemistry or physics usually refer to that change, right? So this is the phase diagram, and there's one more thing that I want you to know. It's called a triple point. Just like how on the boundaries we saw here liquid and gas exist together, solid and liquid exist together, this is called a triple point where all 3 of them exist together. It's also indicated by T and C. So the take-home message from this video is that under a certain condition such as 1 atmospheric pressure and 0 degrees, you can go between the three common phases of water, and in the process you have to either give out heat or take in heat, okay, which we will talk later when we discuss thermodynamics. Now you would see why all these concepts are so interrelated, that you cannot just take out one concept and learn the rest of it. It just doesn't work that way, right? Now this is the phase diagram of water. Now I'm going to show you a heating curve of water in the next video, where we're going to take this two-dimensional graph, which is kind of condensed, into a much more open two-dimensional graph, and see how we can make sense of how our everyday water has go through these various phase changes. All right, so stay tuned.